Now, in this video, we're going to take up a problem on projections of points. First, we're going to consider a problem. A point capital P is 30 mm in front of VP and 40 mm above HP and 50 mm from RPP. Draw its projections. So when you take up this problem here, how to identify that the problem in which this problem falls on which quadrant? So the condition given is in front of VP and 40 mm above HP. So the condition given is in front of VP and above HP. Obviously the condition has to be in the first quadrant. The point has to be in the first quadrant. The first quadrant condition says it is above HP and in front of VP. So the first step what I need to consider is the problem in which we have VP, HP, and since he has given RPP, so we are considering the RPP. That means when you are looking from the front view, the plane to the right side of the observer, so obviously that plane should be right profile plane. And he says the condition is 30 mm in front of VP and 40 mm above HP. So when we are when you are looking from the front view, so that means the observer is looking from here. So when the observer looks from here, that is the front view, the image will going to fall on the vertical plane. The capital point P, which has been shown here, is in space. So when you're looking from the front view, you can see the distance from the horizontal plane. What is the distance which is given from the horizontal plane? The distance given in front of the distance given above the horizontal plane is 40 mm. So from this point till here is the distance 40 mm. But this distance where I can see, can I see from the top view? No. Because when you look from the top view, the direction will going to be in line with the above HP. So obviously you cannot see the depth here when you look from the top view. So obviously I should be able to look from the front view, then only we can see the distance which is in the above horizontal plane. That means I can see the distance only when I look perpendicular to the direction of that particular plane. So when you look from the front view, since the front view is perpendicular to this distance, so obviously that distance can be seen, and that image will going to fall on the vertical plane, and you can see that P dash. The P dash is the one which identifies that the image is on the front view. Whatever the image which falls on the vertical plane is always the front view. So obviously you have to see from the front view, then only the image will going to be falls on the vertical plane, because front view is the direction which front view is the one which is perpendicular to the plane. So obviously we can see the image on the front view, on the vertical plane. And similarly, when you look from the top view is the view, top view is the direction which is perpendicular to the horizontal plane. So obviously you can see the image whatever you see in the horizontal plane will always be top view, because the top view is perpendicular to the horizontal plane. So when you look from the top view, I can see the distance in front of VP. So which is the distance in front of VP? The distance from this point to here. Which is the distance? The distance is 30 mm. So 30 mm in front of VP, I can see always in the horizontal plane. So that distance is 30. And now, when you are considering the distance with respect to the profile plane, when you look from the front, when you look from the top view, so what happens? And this top view is in line with the right profile plane, so we cannot see the distance. Similarly, when you look from the front view, you can see the front view is aligned with that particular plane, so you cannot see the distance. So what is the distance which you can see? 50 mm from RPP. The 50 mm from RPP, when you look from the top view, so the top view is aligned with the right profile plane. I cannot see the image in the right profile plane. Similarly, in the front view also, when you look from the front view is aligned with the right profile plane. So obviously that cannot be seen. But how can I see the image in the right profile plane? I can see the image in the right profile plane only when I either look from the left side view or it should be from the right side view. So the left side view is perpendicular to the right profile plane, or the right side view will also be perpendicular to the right profile plane. So obviously we can see the image in that. But from which direction I should see? Because always the planes are transparent. So suppose if I consider the left profile plane. So when you look from the left profile plane, now the conditions of the observer will going to come into the picture. So what is the condition of the observer? When you look from the front view, the object is here is the point. The object is between the vertical plane and the observer. And when you look from the top view, the object is between the plane and the observer. So these two conditions has to be satisfied. So when you look from the left side view, again the object is between the plane and the observer. But when you look from the right side view, plane is between the object and the observer. So obviously it should always satisfy the conditions of the front view. So what is the condition of the front view? When you look from the front view, the object is between the plane and observer. So this condition has to be satisfied when you look from the left side view or from the right side view. When you look from the right side view, the plane is between the object and the observer, so which is not satisfying the condition of the front view. But when you look from the left side view, you can see the point is between the object is between the plane and the observer. So obviously the left side view will going to satisfy the condition of the front view. Therefore the image will therefore on the right profile plane you will always see the left side view in the first quadrant. So when you look from the left side view, what is the condition? It says the condition is it is in front of RPP. So the condition here, it is 50 mm from RPP, means it should be in front of RPP. The in front of RPP, when you see the distance, which is 50 mm, which has been given here, when you look from the top view, since the top view is perpendicular to the in front of RPP, so naturally that distance is seen in the top view and the image is seen in the horizontal plane. Similarly, when you look from the front view, the distance in front of RPP is seen in the vertical plane. So in other words, if I see, the distance from the RPP I can see in the vertical plane, that is here, and also in the horizontal plane here. So I can see the distances both in VP and also in the horizontal plane. So when you look from the left side view, the image will going to fall on the right profile plane. So as we see the distance with respect to the profile plane, we can see both in the front view and also in the top view. And when you see from the left side view, I can see the distance above HP. So that distance is this one, which will be seen here. And also when you look from the left side view, I can see the distance with respect to in front of VP. That distance is seen here. So this is how you will be able to analyze this problem. And when you look from the left side view, the image falls here, and this distance is above HP, which is 40 mm, and this distance is in front of VP, which is 30 mm. The distance with respect to the profile plane you can see in both in vertical plane and also in the horizontal plane. So if you cut it in short, if I see that when you observe here, the distance with above HP we can always seen in the vertical plane, and distance in front of VP is always seen in the horizontal plane, and the distance with respect to the front plane is seen in both VP and also in HP. So obviously if the distance is given with respect to VP, you can take it in horizontal plane, and the distance with respect to HP, if it is given, you take it in the vertical plane. And the distance with respect to the profile plane, you take both from the vertical plane and also in the horizontal plane. So now this is about the three-dimensional analysis of the problem. Now how to rotate this? Now I will just cut it here. And rotate the horizontal plane by 90 degrees down, and also right profile plane to the right side. So, and when you take the intermediate step, what happens? Let us see. So when you come to the step 2, you can see once you cut it here and try to open whatever the image which is there, that obviously it will rotate with respect to that image only, and similarly the HP is rotating down. So obviously when you come to the step 3, so you can see it is rotated by 90 degrees, So the distance with respect to the profile plane is seen in vertical plane and as well as in the horizontal plane. So that distance is being mentioned here. And also the distance above HP is seen in the vertical plane. So it is 40 mm here. And the distance with respect to the VP is seen in the horizontal plane, which is in front of VP by 30 mm. And so when you rotate that, the distance above HP, which is seen in the vertical plane and also in the profile plane in the vertical direction. And then as you can see, the distance in front of VP in the horizontal plane is at 90 degrees. And when you rotate this by 90 degrees, so obviously that vertical distance will going to become horizontal here. So this distance of vertical should become horizontal in this direction because this distance is 30 and also this distance is 30. So the distance, the conversion from the vertical direction to the horizontal direction will going to take place with equal value only when you are rotating by 45 degrees, because when it is projected here, so this distance vertical will going to become here as 30 mm, and this also has to be 30 because when it is rotated by 90 degree, so that distance is converted into horizontal direction. So obviously this should be at 45 because tan 45 degree will be opposite side by the adjacent side. So and where you have the front view on that line, you will going to get the side view. So this is how you will be able to get the final solution. So whatever it has been given here, we have shown it here. So we have drawn the xy and x1 by 1 line, and first we should identify the planes. In the 5 planes you can see the vertical plane is above xy, so we have represented here. The horizontal plane is below xy line, so we have represented here. Always the profile plane will be adjacent to VP, so the adjacent to VP we have mentioned. And then the distance with respect to the profile plane is seen in both VP and HP. So from x1 y1 line, you measure 50 mm and draw a vertical line, a thin projector line, and then so that distance will going to become 50. And then the distance above HP, which is seen in VP. So from xy, you measure the distance of 40 mm and you just mark that point here and you mark that as P dash, and the distance with respect to the in front of distance with respect to VP is seen in the horizontal plane. So from xy line, you measure the distance of 30 mm and you mark this point which is P, and then the distance is draw a horizontal projector from P dash to the profile plane and draw a 45 degree line adjacent to HP, because we need to transfer the distance which is in the vertical plane, which is the distance which is in front of VP, which is vertical. You transfer that into the horizontal distance, because in the side view I can see the distance of front view and as well as in the top view. The distance of front view is directly projected here, so this 40 will going to become 40 here. So obviously that 40 will going to become here, and here the distance which is 30, which is vertical here, will going to become horizontal in this direction. So obviously that should be angle of 45. So instead of drawing a 45 degree line from here to here, I will draw a 45 degree line here, because once you complete this, it becomes a square of 40 mm side, 30 mm side. So this distance is 30 and this distance is 30. Obviously this becomes a square, and instead of drawing a 45 degree line from here to here, you draw a 45 degree line from the origin, and then you project the top view point onto that 45 degree line, and where you have the front view on that line, you will going to get the side view. So obviously you from this point you draw a vertical projector so that these two lines will going to cut at this point, and you mark that point as P double dash, and then show the dimension of 45 degree and show the dimension of 30 and 40 and 50, and you mark this as xy and x1 y1 line. So this is how you will be able to get the final solution on the projections of points in the first quadrant. Thank you.